We're going to go up to the top here, and I'm going to say northeast, southwest. Okay, so we'll go up to the north part. That's this little bump here. East, we'll go over to that area. South, we'll go down here. West, we'll go here. Zoom in a little more. There, that's my pass point. Could I remember that again? Well, I've given this talk a lot, so the answer is yes. But I don't know how well that would work. It would need testing, but I didn't have to go to the net for that. Sort of interesting. There are you could do Julia sets and stuff. So those are pass graphs, but patent pending for both of those, by the way. Not that I ever expect anyone to use them. So how about another wacko idea? What I really want is challenge response, one-time password. And I don't want to have to carry something with me. I want the brain to figure it out. So, Ches, are you going to have people solve second-order differential equations in their brain? Is that what grandma's going to do? Well, this grandma might be able to do it, but most won't. I'm aware of that. But humans can do something else. They're pretty good with obfuscation. So let's take a look at some related work. Watch this guy. Tap, 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 tap. Okay, he just sent a signal. He just sent a signal to the baseball player who's under a lot of stress, might not be the sharpest knife in the drawer, and needs to get the run, take, steal, whatever the message is. And everyone's watching him, at least some people are watching him. So he is trying to transmit a signal to a human being without being intercepted. And there's a whole bunch of related work. I loved reading this. I spent 2 days reading up on baseball signs. Very cool. How do they do it? Well, they have something that says, all of this is garbage, forget it, except after I touch my nose, the signal is the next one. And then there's a wipe off that says, ignore everything you've seen. So could we do this with a computer? Well, I tried it on myself. Here's the challenge. Username, PID, and date. Somewhere, I picked out a little bit from there. I'm not going to tell you what. And part of the answer, it's the 4 there that matters. If that 4 weren't there or weren't a 4, this would be an invalid login. All the rest is garbage. Okay, so I'm obfuscating the challenge, the response is obfuscated. And I ran this for, you can see, a while, and after a while I got sick of it and started giving shorter and shorter unobfuscated answers. And this answer, this 4, was correct, but it shouldn't have been allowed. I should have required a long answer. But it's sort of liberating to say, I'm typing in my password and I don't care what I type because I've already given it what it needs. Boom. So maybe that would work. The literature for this pass authentication goes back to 1967, where they described somebody whose challenge in 1966 had set up a challenge of an assembly language instruction, and the response was the machine code for it. Okay, so these tend to be idiosyncratic, techie, geeky sorts of things. Do you have your own pass algorithm? There are a whole bunch of different names for it, for doing this sort of thing. I don't know if it's going anywhere, but people have tried to do this. The great thing is if it worked, you could save the banks a lot of money. And so that was worth playing with. Updated advice, as I am running out of time. For users, use 3 levels of passwords. I don't care if the New York Times cares that I have a password. I don't care. So I give them a password. Okay? Inconvenient if stolen, that's sort of the Amazon level. I mean, it's still, even given my password, it's hard to buy a lot of stuff without Amazon noticing. Major problem, bank, medical records, maybe, stocks. Write down the ones if you must. It's okay. Though I don't write down the password, I write down something that reminds me of the password or is close. So someone has to think about it a little bit. Use variations to meet the strong password requirements, and just note the variations. The usual strong password, but no spaces. Save your passwords with Firefox. Well, these things, I haven't done a full security analysis of them. I think there's probably somewhere buried in there a dictionary attack that someone on your machine could run. For implementers, that's you, isn't it? Count and manage the authentication attempts with a server, not with the application you're running. A server is one place where you do one job and do it well. It's the old Unix philosophy from way back when. PAM tally. You may not have known about this PAM module. It actually counts the number of logins attempts and locks it, and you can just drop it in the PAM file so SSH can have it. There's actually a PAM tally too. It's been around for about 12 years. I had never heard of it till I went and said, we really need one of these. And I found someone had done it. I'd like to see it rewritten to a cleaner code. It's sort of Linux-based. Anything should run on both Linux and Unix and so on. Slow or block accounts slowing it is better than loss of control of an account. Blacklist IP addresses. Now, I know they're going to attack you from botnets, so you may end up blacklisting a lot of them. But, that's from one I don't like much. I'm only going to give him one answer per day. And avoid strong passwords whenever you can. Use an authentication server. Don't let it be compromised. That's so embarrassing, and it gets you out of the authentication server business in a hurry, or it should. I really like the OpenID, OpenAuth ideas. I think this is a great approach. Let's get it right and make it work. It ought to be AT&T or somebody like that. You log into your bank, and it says, which authenticator do you want? Ask AT&T who I am. Little thing pops up. Okay, AT&T says you're okay. That would be an AT&T service. As far as I know, we don't have such a service. I think it'd be a great idea. And you pick someone who people generally trust. And believe it or not, people do trust AT&T. Identify the auth server. I talked about that. Don't make account names too easy either, because people will either guess this way, lots of passwords, or this way, lots of accounts with one password. And you want to slow both of those things down. A PIN is not a password. A PIN is digits only. Don't get the names mixed up. Get out of the game. Disable password logins on SSH. Don't do that. Don't use it. Use the DSA key stuff and lock it with a passphrase. I know maybe you won't. It's much stronger. And then you can laugh when you get all those logs of people trying to log in from Latvia. Frankly, folks, we have to do better than this. There's plenty more to worry about. There's all sorts of dangerous stuff. Dangerous browsing. Nice paper. All your iframes belong to us. Even if you go to virtuous websites, the advertisers call each other deep until you get to a bad place. This is an alarming paper to read. Dangerous patches. Don Song, who has been the source of a whole bunch of really great ideas, found that you can analyze patches as they're released automatically and figure out what they patch and generate something to exploit them. And this takes a few CPU seconds. Can even tell parts of the patch that don't work. From the same swell, folks, provably hidden malware. There's no promise that virus checkers are going to work forever, and they're not. Dangerous CPUs. We've always known that supply chain problems are a problem. What really gets me with this paper is how they activated the badness. Okay, there were bad transistors in the CPU they had. How did they wake it up? You send a UDP packet to it with a bad checksum. The CPU reads through the UDP packet, which has special bits in it, and when it's done, the special bits that appeared on the data bus tell the CPU to stop doing memory checking. And then the bad checksum, it throws the packet away. There, see, it's working fine. It's just you're now running with your pants down. So anyway, that is my talk, and I'd welcome a couple minutes worth of questions, and I'll be around for the rest of the day. I'd love to chat with you. Thank you for your attention.